Good afternoon. My name is Başak Saraç-Lösar. I'm a postdoctoral associate in the Department of Science, Technology and Society at Virginia Tech. I work with Sonia Schmidt on the NSF Career Project Globalizing Nuclear Emergency Response. Welcome to SIREN. This is the 24th event in a series of seminars, talks, and discussions on the nuclear emergency response. The series is part of the NSF Career Award on Globalizing Nuclear Emergency Response. And in the spirit of this kind of grant, we emphasize the importance of both research and education in the area of nuclear emergency preparedness and response. All SIREN speakers are meeting with graduate students as part of their engagement, and we plan to provide access to a recording of their lectures. SIREN, the Seminar on Interdisciplinary Research and Education in Nuclear Emergency Response, is generously supported by the Virginia Tech's Office of the Vice President for the National Capital Region and the Policy Strategic Growth Area. Many thanks to the staff of the Virginia Tech Research Center's Executive Briefing Center and the IT team for their support, and to the students, staff, and faculty in the Department of STS for helping to make this happen. Today's talk will be live streamed, and we have over 70 remote participants signed up as of this morning. These attendees are joining us not only from our main campus in Blacksburg, other US universities, federal agencies, and national laboratories, but also from Canada and Europe. Welcome. If you are watching us online and would like to submit a question to our speaker, please send in an email indicating your name and affiliation to siren@vt.edu. Our next event, the final before summer break, will take place next week on Thursday, May 3rd. Dr. Klaus Gerke, the head of the Division of Radiation Protection and Environment in the Federal Office for Radiation Protection in Germany, will talk about the long way toward harmonization in German nuclear emergency response. Please help us spread the word. We have one more announcement. ARI and the Nuclear Engineering Program are hosting a talk by Tevfik Elahi Chowdhury, advisor to the Prime Minister for Energy, Power and Mineral Resources Affairs, Government of Bangladesh. The talk is titled Rationale for Nuclear Power Development in Bangladesh. It will be on May 2nd at 4 p.m. in this building and will take place in the room 3-024. And now it's my great pleasure to introduce our speaker today, Mr. Lake Barrett. Mr. Lake Barrett has worked in the nuclear energy and nuclear materials management for 5 decades. He currently serves as specific advisor to Japan for the cleanup of the Fukushima Daiichi accident. Earlier in his career, he served as the head of the DOE's Office of Civilian Radioactive Waste Management, which was responsible for implementing the U.S. nuclear waste program as mandated by the Nuclear Waste Policy Act. In that capacity, he led the Yucca Mountain Geological Project throughout its many crucial and difficult phases. As we all know, the Yucca Mountain Project has been subject to many techno-scientific and political controversies, and we might all have very different opinions about whether it was a good option or not. However, here I would like to take the opportunity to acknowledge the determination with which him and all the Office of Civil and Radioactive Waste Management, geologists, hydrologists, accountants, engineers, or the users of Yakamaker, the tunnel boring machine, have worked over 30 years towards the completion of the nation's nuclear waste project. Take alone all the budget constraints and the numerous continuous resolutions under which the program was run should be sufficient to put us all on the same page. Lake Barrett also served at the U.S. Nuclear Regulatory Commission, where he was directly involved with the early response to the 3 Mile Island reactor accident. As site director, he was responsible for regulatory programs during the stabilization, recovery, and cleanup of the damaged reactor. Mr. Barrett has also had extensive managerial and engineering experiences in the DOE's defense programs and private industry, at both Bechtel with commercial nuclear power plants and General Dynamics with nuclear reactor and submarine systems design, operation, and decommissioning. He has degrees in mechanical and nuclear engineering, and he has been the recipient of various presidential and congressional honors. Please join me welcoming today's presenter.
Thank you, Barsik. Appreciate the introduction. Is the sound system working all right, we think? All right. All right, well, thank you very much for Virginia Tech to provide a chance for me to sort of take a trip down memory lane here a little bit. What I thought I would try to do is give you a quick Sesame Street version and pictures of the 3 Mile Island accident from the very beginning to the end of the recovery period and the cleanup period as well, and then talk more about the details of what we call Black Friday, which was March 30th when the evacuation occurred, which I was unfortunately very much part of. So let me kind of see if I can make the machine work and talk to you a bit about 3 Mile Island. And I get the button. Okay. Given that this is a university setting with various people who want to watch it, some people get very concerned about nuclear. They think nuclear is very risky, it needs to be curtailed, the Germans aren't going to do it anymore, and they're going to go to wind and solar, which is like risk-free. There's no such thing as risk-free energy. Now, we won't go into a general energy discussion here, but every source of energy has impacts and risks and costs, and including nuclear. So this is going to focus on nuclear and emergencies, but actually, in my opinion, I think nuclear is one of the lowest risk energy sources that we have for modern society. So with that said, let's move on into 3 Mile Island. 3 Mile Island is Babcock and Wilcox reactors. There's 2 of them, twin units. In the foreground is the Unit 2 reactor, and in the background is the Unit 1 reactor. These are located on the Susquehanna River, about 10 miles south of Harrisburg, Pennsylvania, and the Susquehanna River is the main tributary to the Chesapeake Bay, and is a freshwater river, and people drink it downstream in the cities of York and Lancaster. This is a picture of 3 Mile Island looking down on it. And this is a view from Goldsboro, which is on the west side of the river, and you can see the cooling towers, and many of the people work there. And Middletown is the town on the east side. It was owned by Metropolitan Edison, which was a subsidiary of General Public Utilities. As I mentioned, it was 10 miles south of the state capitol. These were 2 B&W reactors, and they were basically twin plants, though the Unit 2 was rated a little higher. One thing the accident, there was only 93 full power days on the Unit 2 reactor, which was the one that was damaged. That's like driving a brand new car out of the showroom and crashing it. And that's exactly what the operators did, unfortunately, on March 28th. Now, just a little bit of setting to what was going on nationally at that time in March of 1979. Some of you may have heard the term China syndrome. This was a big issue in the China syndrome kind of thing, even in the time of Fukushima. There was a very popular movie out where a very controversial person who really looked good was Jane Fonda, okay? Hanoi Jane, as some might remember her, okay? It was a movie that very much was in the post-Watergate feeling of the time, distrust of establishment, distrust of government. It was very anti-military, anti-nuclear type of movie. It was anti-corporate, distrust of corporations, and it was all about the concept of a reactor meltdown and the reactor core melting its way down through the base mat of the containment, through the groundwater, into the center of the earth, and come out in China. Now, it's scientifically impossible, but it made a heck of a good movie. Now, this movie was released on March 16th, 2 weeks before what actually happened. And if you look carefully through the movie, you will find so many almost exact same words that was in real life at the time of TMI. This whole concept put a huge amount of stress on everyone at that time. Not us in the industry at the time, because I had not seen the movie, but I'd heard about the movie from some of my neighbors. But if you would watch the movie and you watch the news, especially the evening news with Walter Cronkite, you got a bad feeling about this whole thing. But anyway, let's talk about the accident. It started off at 4 o'clock in the morning. It was a very simple. There was a minor condensate booster pump tripped, which caused a feed water trip, which caused an automatic reactor scram. Everything is pretty normal. However, there was a small valve on top of the pressurizer, pilot operator relief valve, that stuck open. The lights on the control panel said it was closed, but the light on the control panel, it said the signal was sent to close, but the valve was not closed. The valve was open. And if the operators had known that valve was open, it would have been over in 10 minutes, and it would not have been not an accident at all. But this is the picture of the valve, not a very big valve, not yay big, okay, and it was stuck open, and it was basically giving a false indication to the operators. Now, what was happening, it was a small break small break loss of coolant accident, which was analyzed for. The 1979 computers turned on the high pressure injection pumps, and the operators, unfortunately, turned the pumps off because they believed they had the bubble. Now, we can talk about it later if you want to go into it. This is an old jargon from nuclear people. You never lose the bubble because it means if you lost the bubble in the pressurizer, you've lost pressurized control on the pressure in a reactor. And anybody that has ever been involved with a Navy reactor or a pressurized water reactor is you never lose the bubble. The worst thing an operator can ever do is lose the bubble. These operators, there were 4 of them. They were tested. They were qualified for the job. They actually did quite well on their tests, okay? But they thought they had lost the bubble, and they had too much water in it, and you just did never, ever let that happen. They were used to a response from a Navy-type reactor. These were Navy operators, very good ones. The Navy reactor steam generators are different. They have more forgiveness to them. They have a lot of thermal inertia. This is a Babcock and Wilcox reactor, which is a superheated steam generator, so it does not have thermal inertia to it. It's somewhat like I would describe if you're driving a recirculating steam generator reactor, it's like driving a big old Cadillac with a big old wheel and a big old soft, and it's very forgiving. As opposed you're driving a little sports car, a little Ferrari kind of thing, where you turn the wheel a little bit, boom, it goes off fast. These operators got confused. So that morning, they basically lost control of what they're not nuclear control. The control rod's inserted. We never had a recriticality or anything like that. But as far as the coolant, and basically they got gas inside the reactor. They overheated the core. Many excuses why they did what they did. They thought they were doing the right thing, but they basically had lost control. And what happened was the core was uncovered in about 2 hours. In 3 hours, it was overheating and starting to oxidize. And at 4 hours, they had melted down at about 8 o'clock in the morning. None of this was known then. They thought they just had a thermal transient. Now, a little bit about they got high levels inside from the failed fuel. They did declare a site emergency, and then following their procedures declared a general emergency at 7 o'clock, and the company made their notifications as they were required to do, and did that well. What happened, much of this we learned weeks later, or sometimes months later. The actual hydrogen gas was released into the containment, and that actually burned. It was a deflagration at 1 o'clock. They thought when they heard the thump and the boom, they thought it was a damper closing, but in reality it was a deflagration. It was not an explosion, because it's like you turn your gas grill on and you don't put the match in right away, and you wait a while, you wait a minute or two, and then you put the match in as a big flame front comes across and a pressure front. That's what happened. So it was not a supersonic shockwave event, but nonetheless, it crushed drums that you would see. It caused flames to go through. For those of you young students, that's a telephone in the lower right-hand corner, the old dial one. You probably have never seen one of those. But anyway, that is all fused together as the flame front went through, and the plastic was fused and burned together. And the wood was charred. There was 3 meters, 10 feet of water in the basement, highly radioactive. Over 1,000 R/hour. We learned that later when we sent people inside. But I mean, basically they made one hell of a mess inside the containment. But the containment was meter thick, reinforced concrete. It was strong. It held a pressure spike. And it was not like Fukushima where the building came apart, and it was not overpressurized at all. So the fundamental safety systems worked as they were designed to do. But to cool the core, they needed to run the main coolant pump to force water through, even though the core was greatly degraded, and the water was very highly radioactive. It had about 1,000 cubic feet of non-condensable gas inside. That's primarily hydrogen, but also there's some helium from the core because the fuel pins are helium loaded, and steam, of course. They had to run and do letdown, meaning bringing the water into the auxiliary building. And I'll go into more of this in details on what caused the Black Friday. But basically, most of the releases none of the releases came from the containment building, because it was subatmospheric. Once the oxygen and the hydrogen burned inside, it actually had negative pressure inside. But from the auxiliary building, from the letdown. There's a lot of miscommunications. I'm going to come back to this in more detail. But this was on the morning of Black Friday on the 30th, and there's a helicopter, and I'll tell you more about it. But there was a lot of misunderstandings, bad information, miscommunicated data that was going through the system, both within the NRC and to the state and the utility. There was a precautionary evacuation decided on that Black Friday. There were minimal off-site releases. In reality, not what we thought the case was. And mostly noble gases. There was some iodine. There was iodine released. There was great media sensationalism going on. Some of it based on the movie. Governor Thornburg, based on the uncertainty, issued an advisory evacuation for pregnant women and children to leave that day. Now, way beyond what was expected, 140,000 people left, about the same number as Fukushima, okay, because people just didn't trust the whole situation. Now, the company, the utility, as Jack Irvine and Herman DeCamp, the president and the vice president of the company, they had a terrible time communicating with the public. This was pre-internet days. And I can imagine what this would be like today with the internet. But back then, the reporters were listening to radios, which people would radio in basically the findings of their sampling. So many times the reporters would listen. They would know things much more than a company executive would, who'd be briefed to go into a briefing. But basically, there was such huge distrust that the company was not believed whatsoever. They said, you're just like those guys in the movie, trying to make money and suppress this and do evil things to us. And they were not at all. And actually, you go back in the records, the company explanations about what was going on was much more accurate than anybody else's. But a lot of things they did not know, okay, at that time. Very similar again to Fukushima. In many cases, they were better informed than we were at the NRC in Washington. That I will tell you. But anyway, President Carter, with all the concerns of Friday and the misunderstandings, said we're going to have one federal spokesman, okay, who was going to do that, and that was my boss, Harold Denton, on the right here. And Harold was sent as the president's designee to be the single federal spokesman for what's going on. And then he became the interface with Governor Thornburg. But the reporting was on a world of its own. It had taken off like a rocket. I mean, this is a typical thing in the paper. Thousands flee because they're trying to prevent a meltdown. I have a wife and a child, get out now. This is the typical phraseology that was there at that time. I went and lived there 4 years afterwards, and all my neighbors in Pennsylvania would ask, well, if you'd been here, would you have left? And I said, well, based on what I would have seen then or what I really know now? And they said, well, based on what we were. And I said, yeah, I would have left. I would have told my kids to leave. I'll go into detail later on. Joe Henry, who was the chairman of the NRC at the time, excellent technical man. He was asked by Governor Thornburg, what would you do with your children? He said, well, on uncertainties, I think I'd have them leave right now. And that's what he said, because of the uncertainties. Well, anyway, the evacuation took place. We had about 140,000 people. It cost $70 million, a lot of money back then, but it was paid for by the insurance. The difference here, in Fukushima, everybody went home in a week. There was no off-site contamination to speak of. But President Carter came on April 1st. That's the Saturday after Black Friday. I do a little Fukushima story sometimes. You know, it's not like when Prime Minister Khan went to Fukushima, Carter staff asked, is it okay for the president to come? Would it be helpful? And we said, yes, it would be helpful on Saturday. You know, but if it was Friday, we would have said, don't come. Prime Minister Khan never asked. But anyway, but it's President Carter, and more importantly, he brought Rosalind, his wife. That was important. Happened, the entire American nuclear industry banded together, we need the help, and it did. And so the Navy nuclear programs, other nuclear utilities, sent their best and their brightest, and we had 1,000 people, and this is the trailer city around the visitor center, which is on the right-hand side there, around the house, which I'll tell you about the house later on. Anyway, cooling was established in the afternoon of March 28th. Didn't know all the details, but basically it went to cold shutdown within a month. The accident water was retained, never was released to the river. And there were some iodine releases, and there were a lot of noble gas releases, but the off-site consequences were very small. We can go into numbers if you want later on, but basically there's no radiological impact that you're ever going to see from 3 Mile Island, and all the studies since then have verified that. But you will still see reports, even in contemporary press, somebody has thyroid cancer, or there's a pocket of thyroid cancer somewhere, you know, in the Lancaster area, and some of that was scientifically true statistically. There are a lot of Amish people live in Lancaster County, and they're very much interbred, okay, and they will have a higher incidence of thyroid cancer, but they had it before as well as after. But the impacts were very, very minimal. Once the accident part was over, then it was basically, let's recover from this accident, let's clean it up. So all new systems were basically put in place. New management organization put in place, new people. A national finance policy plan had to put together who was going to pay for the cleanup nationally, and so arrangements were set up to shared costs between the states, the federal government. This was the time of Ronald Reagan. There was to be no Chrysler bailouts, so this was no corporate bailouts involved in this, and we can get into those policy things if you'd like to go on. A bit about the technical recovery. I mean, basically, you know, we developed specialized equipment and specialized procedures to basically clean out the melted core and the radioactivity that was spread all around, and you start off with the basic principles of things. Air, water, you know, earth and fire kind of thing. First, you make sure it's cool, you got the energy dissipated, which was done pretty much in the first few weeks, because the decay heat was down. Then you have to control your airborne, you have to control your water, and you have to control your solid waste. All right, and you have to transport it off-site and make sure this is all done safely and promptly. So it's a bit about ventilation systems. We had krypton in the containment. It had to be released. Krypton was a very emotional issue because you all know what's the only thing that can hurt Superman? Krypton, right? Krypton gas was going to be vented. It was always on the front page of the paper, which way the wind was blowing when they were venting at TMI. It was that way for 2 years. Every time you look at the most popular page, the funny page, you would find out if they were venting krypton or not. But we put in ventilation systems, charcoal, HEPA filters, et cetera. But airborne systems were done very well. We had to build special water processing systems to handle very high levels of cesium and strontium. And so this is some of the specialized water systems we developed. And this was developed basically from the time the DOE, AEC technologies for fuel reprocessing, because there was those kinds of levels. The containers that we put the cesium in were the same as basically spent fuel of today. The solid waste management systems had to be developed for various types of new waste that we produced that had never been done before. Disposal, concepts had to be developed and done, which we did these with basically teamwork between national laboratory, nuclear industry, states, and others as well. Then getting toward the melted fuel inside, we worked just carefully from the inside out, from the outside in. First, we developed ways to look inside and do characterization inside to find out what the damage was. Nobody knew how damaged it was. Most people did not think there was fuel melting. We didn't learn that for several years. Basically mapping and drilling and working our way in, we found out, yeah, the top 5 feet of the core was gone. It was all slumped down. And yes, it had melted inside. The fuel had oxidized, meaning it burned, okay, as we would do it. We had to redevelop a lot of the equipment inside, such as the large 100-ton crane up at the very top called the polar crane. This had all been burned, the wiring was all shot, so we had to basically rebuild that in a radioactive environment, and this is one of the first people going up on top. There were many issues as we worked our way through from the outside in. We needed, after we refurbished the polar crane, there were some anti-nuclear people who said the crane will fail and they'll drop the 40-ton missile block. That's the missile block you see there. I had to assure the governor, no, that crane has been well tested, well verified. And he says, well, you're going to be in there? I said, yes, sir, I will. So that's me suited up to go in there. When we lifted the missile shield, following the lowest reasonably achievable, I was the photographer, so I took the picture. So not only was I the director, but I was also the photographer. But anyway, we developed decontamination processes. These were all evolutionary processes. You know, first you could do it manual, then you'd have a machine, and then we actually had a robot that would do it, even in 1980s. So, you know, we would develop things in an evolutionary manner as we go. We had to develop a new defueling plan to minimize the amount of water we had, so I won't go into detail on that unless somebody wants to do it, but basically using the shielded bell to move fuel. A lot of this was kind of copied off of the way some of the AEC and some of the Navy reactors were defueled at that time. Then we started working our way down with a specialized shielded platform for the workers using long-handled tools, very specialized tools to basically go in and pick the pieces up and put them in a canister. This is the shielded transfer bell. These are some of the spent fuel cans down at the bottom where they were poisoned, so you wouldn't have a criticality event. We also had catalyst in it for hydrogen generation. Basically, a lot of technical safety issues we had to deal with. We had a special boring machine that would actually drill it because the center of the melted core was too solid and too tough for the long-handled tools and hydraulic chisels. So I actually drilled it, and it's called Swiss cheesing. You put holes in it, and then you could break it into small enough pieces to put inside the fuel canisters. A new cask was designed for transport. It was a 125-ton cask to basically move the fuel to Idaho. A big social political issue was where the fuel was going to go, and it went for research and development purposes, not for long-term storage nor disposal. To Idaho, went across 11 states. We had lots of different stories to tell you about dealing with different governors who were under political pressure not to let this dangerous thing go through their state, but we did it at the time. This is a picture of the cask and with the impact limiters removed from it, being unloaded out at Idaho. This is one of the actual fuel canisters on the left being withdrawn from the shipping cask. And through the analysis of the material in this, they had a very good safety map of what really happened inside the 3 Mile Island. So we learned a lot about the strengths and also the weaknesses of the design, but basically made them safer and less risky for the future. So then when the R&D was done on that, the fuel was put into storage canisters, and here the fuel, the 93 tons of fuel, sits today out at Idaho waiting for a national disposal program, which hopefully will be Yucca Mountain once we finish with that political issues. But that's where the fuel rests today. So the sister reactor, Unit 1, was shut down for refueling at the time of the accident through a long 6.5-year process, public process. Improvements were made, primarily on the operator training side and also the NRC as well, plant modifications. It restarted, and it's been one of the best operating reactors in the United States over the past 30 years. Unfortunately, it's probably going to be shut down in a year or two because of the economic situation and the wholesale price of electricity. We had a new chairman. This is a picture of me going with the new chairman, Palladino, into some of the public hearings. So we had lots of challenges with that. But we were in a very open and transparent and public manner, as it should have been. These are sort of history things about kind of what happened on what dates. I won't go into that. You can look at it later if you want. The total 14-year cost for this was about $1 billion of then-year dollars. If you put that into 2012 dollars, it's about $2.3 billion, relatively inexpensive. Japanese at Fukushima spend more than that every year. One thing about TMI and the recovery and cleanup model became actually a very managerial model for much of the growing U.S. cleanup industry. which became later on Department of Energy, as we basically cleaned up the Rocky Flats plutonium facility and many of the Hanford and the Savannah River, as the old, in the World War II primarily starting, facilities are actually being decommissioned and cleaned up and decontaminated. So much of how you would gather in the technology, the advanced R&D, and apply them in a practical way in a real dirty plant are things that we effectively met those challenges well. Also, much of the managerial approach that we took has also translated into the commercial reactor cleanup programs. I mean, we have over a dozen reactors today that are shut down, and 6 of them have been totally greenfield today. So this is not an uncommon thing, but many of the things we learned in the first major decommissioning operation also became valuable later on. We had to improve community relationships. We had the first of the site advisory panel at 3 Mile Island under the federal law. This has been replicated at virtually every reactor power site in America, as well as all the DOE sites. This is a picture of me doing one of the first briefings there in 1981. But one of the things that we learned from 3 Mile Island, I mean, it was a terribly painful experience. But in your life, if you look back, the most painful experiences are also the most teachable ones. And in the case of TMI, from sort of before and after, I mean, the stress is gone. I think everybody is wiser. The communities around the area, 3 Mile Island, are very strong today. And all of nuclear power is truly safer and more productive. Now let's go into more of the details of the accident and some of the emergency management things that happened in those first days. First of all, I'll give you my personal recollections of it since I was involved. But also, if you want to go read 1,000 pages of it, it's in these 2 reports, the commission, the CHEMINI, that's the President's Special Commission on it, okay, and the Rigovan report goes into it even more detail. So there's a 200-page one, and then there's a 2,000-page one. So take your pick. I'm in both of them. This is kind of the first time I've had to sort of do this down memory lane, because last time I did it, it was, when I was in the deposition phase by the inquisitor lawyers, is when did you stop beating your spouse, and why did you do these terrible things? So one of the things I would say sort of is information is critical. You're dealing with human people. You act on what you believe is the situation, okay? No matter what organization you're with, if you're utility or DOE or anywhere, NRC or whatever, everyone was acting in what they thought at that time was in the public's best interest. Turns out facts were different than maybe you thought they were, but you act like you believe. If you go vote, you vote on what you believe the situation is, not what the situation really is or not. So you act on what you believe. Now, sometimes that information might be wrong. I mean, that's kind of, you look back, we did not have the right information on the whole thing. Now, a little bit about how the organization was at the time of TMI, and it's still not terribly different today. There was an executive management team, and I'll kind of talk about that a little bit more. This was basically all the big bosses were in the Bethesda Incident Response Center, okay? These are my bosses, boss at the time, okay? Type of level, all right? So these were the top people. All right, then you had the technical people who were an incident response action coordinating team. That was what the official title was. Basically, we're the technical support staff. We're trying to evaluate the information that we're getting to give advice and explain to the bosses, the management team, here's what we think is going on, okay? Now, this, at the time of TMI, it's now been changed, but there was basically 2 types of NRC people. There were the licensing people and the technical evaluation people, which are basically in the Office of Nuclear Reactor Regulation. I was one of those people, okay? Then you had the field inspection and enforcement people. Those were the guys in the regions. I'll say guys back then because there were very few women. It's different today, as it should be. But they were the ones who go out to the field and do the inspections. They had the checklist, okay? They didn't really get into the details about what if this and what if that. That's kind of what the NRR people did. You had these divisions of labor, and you had different mentalities about how you went about your jobs. One of the fundamental problems we had is when you had the real accidents, you had to have both at the same time. Now, I had a little experience as a Admiral Rickover contractor, okay, of having some operational experience as well. I was trained to be a reactor operator on S5W reactors. But I had a little bit of field experience as well as, but I was a technical reviewer, okay? Now, the Office of NRR, the technical people, were supposed to support the inspection enforcement people in an accident response. That's how the procedures were written at that time. But it got so complicated that it was beyond what the procedure said. I&E people, especially, they were very procedural oriented. Show me the paper and I'll make sure they follow that rules. There was no paper for this. There was no procedure for this. So it became, well, what do you really think is going on here? So there was a shift in the Incident Response Center from what should have been an IE dominated with NRR support. NRR started to dominate it. For example, this was the emergency responder organization. You can look at it later on, but I mean, the EMT was the managers, the top managers were the bosses and the technical people below. But the IE people, and that was formed, were going to just communicate back from the plant what was really going on. Well, they didn't have the information. So there wasn't anything to communicate. You had to evaluate what snippets you had. It's like you had a movie and you got to see every 100th frame. And you got to see the 100th frame of the movie 2 days late. Because in reality, if you look back, the information flowing into us in the emergency response center was often 2 days old. You know, you think, well, how could that possibly be? And we can go into that more in the question and response later on. This was the way the room was set up. And this is a pre-accident thing. The EMT is the room, the little horseshoe, that's where the bosses were. And you had the different systems engineering, radiological agents, they had office rooms outside where they could do evaluations. We all had access to the messages, which were handwritten notes, okay, and telephone calls. And then we had sort of a central room. But after the second day, things started to change a lot. The inspectors kind of found other things they felt they had to do, and it fell onto other people. And I was one of those other people. I was never trained to be in this room. Don't know what I did. But I became sort of this. There were two of us who were doing radiological analysis. My boss, Brian Grimes, and me. Neither of us were trained ever to go here. He had days, I had nights, which entered into being part of the problem. Okay. We ended up, the IE people some of the psychologists said they abdicated, but they did the best they could do. And they were vital to us because they knew more about the plant than we did. But we knew more about the theory than they did. Today, it's changed. The inspectors have a whole lot more theory, and the theory people have a whole lot more operational experience. But then it was not that way, as it should have been. So let me talk about time. Wednesday evening, when the thing first happened on Wednesday, I remember being in the office on Wednesday, and they said, well, they've declared a general emergency at 3 Mile Island. We don't know what it is, but they've got extremely high radiation levels, and they think it's a crud burst. Well, crud burst is cobalt-60 and radioactivity that builds up from neutron activation. This was a brand new plant. There was not much cobalt-60 in a brand new plant. So, well, he thermally shocked the fuel due to a transient. In technical, you can't get radiation levels like this with that. So, there was a lot of questioning that, do they know what they're doing? And it just didn't make a lot of sense. But we were, the system was set up, the information was flowing, but there was widespread frustration, I'll speak from the NRC side, about what was going on. There was a growing sense of uncertainty and trust. Do they know what the hell they're doing in that control room? Okay? Because we started to see things like temperatures off of thermocouples that were superheat when there should not have been superheat, okay, which is indicative of an exposed core. We sent Dick Vollmer, who was, actually wasn't my boss, but he was sort of like 2 levels up and to the side, but Dick went to the site, okay, and comments were, he went on Wednesday afternoon. What's Vollmer telling us? Well, he fell into a black hole. I remember that comment and discussion, He had to actually go into that house next door and borrow the people's phone to make a call. He actually had to drive his car into Middletown to get his payphone to call NRC headquarters. Communications were that bad. It was so noisy in the room one time, he had to crawl under the desk to get the ambient noise level down so he could talk on the phone. That's how bad it was on Wednesday night and Thursday. Thursday, people say it was the quieter day. It was a quieter day, but the information was then starting to come in about how significant it was. We discovered, yes, we did have superheat temperature. Yes, the core was exposed. The information we got from the operators, no, the core couldn't have been exposed because there was too much water in there. There wasn't too much water in there. There was a steam bubble, okay? We discovered that there was a containment pressure spike, that they did have a burn inside the containment, which meant we had fuel oxidation, okay? We finally got a sample out of the primary coolant. I mean, it was screaming hot. It was 1,000 hour per hour contact. Radiation levels you'd never, ever see on a sample, okay? You know, we're talking 6 orders of magnitude greater than what should have been there. I mean, this was a big shock to us. Radiation levels of well over 100, pushing 1,000 hour per hour in normally occupied spaces in the auxiliary building. And we had 1,000 cubic feet of non-condensable gas in the primary coolant system in the form of bubbles. Now, we concluded we had a severely degraded core. Somehow they really, we didn't know how or what they did. We didn't know about the stuck open relief valve then. There was a very sad situation. One of the engineers came in at 7 o'clock, just before the core started to really degrade. He asked the operator, is the block valve closed on the PORV, which was on, and the answer was, yes, it's closed. What the operator didn't tell him was, yeah, I just closed it 10 seconds ago. If you told the engineer, yeah, it was open, but I just closed it. He said, well, you sure the PORV wasn't stuck open? Because I had a trouble with that at Davis Bessie a few months before. So just a simple thing like that would have maybe prevented the core from being severely damaged. But the stars were not aligned for that on March 28th, okay? But we didn't know this. So what I was doing Thursday night, now, I was never planning to go there, but my boss stayed Wednesday night. Brian stayed Wednesday night and part of Thursday, and he was tired, and he needed to sleep because he started making not so good judgments. So I went in Thursday, okay, and I basically took over the evening shift. And what we're trying to think ahead to support the EMT. They said, well, what's next? What's going to happen next? I don't know. We started to look. So, okay, we know, here's what we do know. We knew we had condensable gas. We knew we had high radiation levels. And so during the night of Thursday, okay, I was concerned about the degasification and the high radioactivity levels that we had in the auxiliary building, where it was being degassed through a compressor to put it into a waste gas tank, which had relief valves that would overload, and it would just blow straight out into the stack. And all we had was this one sample, which had screamingly high radiation, and we did an analysis, and I did an analysis quickly that night, basically that said, well, if the tanks are full and the relief valves lift, I think we're going to be somewhere in the neighborhood of 1,200 MR per hour at the site boundary, okay, which is getting close to the EPA protective action guidelines at the time. But again, this was hypothetical, trying to think ahead. But we knew we had condensable gas, we knew we had radiation levels, and we knew we had to degas that makeup tank because we had to run the seal injection to keep the main coolant pumps running. So we couldn't stop it, okay? And the plant was wrestling with us too. But we had maybe 5% of the information that the plant had, okay? And so on Friday morning, okay, I was kind of trying to think ahead, what if? Brian was supposed to relieve me that morning, but he had to go to a commission meeting, okay? He was a senior guy, he had to go to a commission meeting. So he's downtown, I'm still there, okay? I'm tired, okay? I'm frustrated, but so is everybody else in the darn rooms. We're tired and frustrated. So I'd finished my analysis around 8:30 in the morning, this 1,200 millirem, and John Davis, who was the director of I&E. Now, he's one of the four top guys, okay? We worked there 3 days, 20-some hours a day. You got to know each other, right? So he's over my shoulder. I was on the table. He says, something new? I said, well, don't know, but I said, eventually, watching the waste gas decay tanks, they may be getting full, he said, well, if they get full, it's, well, don't know for sure, but I think maybe around 1,200 MR per hour. Is that pretty high? I said, we're getting there. That's not where we want to be. And at 8:45, in 10 minutes, we get a site message that the waste gas tanks were full, uncontrolled release, okay, was occurring. Now, the message that the waste gas tanks were full was wrong. We didn't know that for weeks. Okay, uncontrolled release, we knew was true because they told the state of Pennsylvania it had uncontrolled release. So John says, is this important? And I said, this is kind of important. He says, well, come right in here and brief everybody. So I get escorted into the EMT. Now, this is all the higher level people. This is now 9 o'clock, so everybody's there. Air Force General, nice guy. Kind of didn't really know reactors very well, but a good manager, okay? Harold Denton, my boss's boss's boss, okay? Harold was in charge of NRR, sort of line away if we're going to make a decision. Ed Case, Edson Case, his deputy, very good guy. Vic Stello, my boss's boss's boss. Vic was a superstar engineer. John Davis, director of IE, good guy. Doc Collins, who was state planning guy, state liaison guy. They're all sitting around that little horseshoe table, the boss's table, right? And they said, okay, what the hell's going on? So, well, we got this report that the tank is full. And they said, what the hell does that mean? I said, well, we don't know, but it could be 1,200 MR off-site. So I say 1,200 MR off-site. I think it was Doc Collins said, I got a report from the site. It's 1,200 MR per hour reading. The report was, let me see if I get it right, from this helicopter, 130 feet over the stack, okay? It was not at the site boundary, but there was a 1,200 MR reading, okay? And the site had declared uncontrolled releases, but the site boundary dose was about 10, 15 MR per hour, low, not evacuation level, okay? But it was within 10 seconds. I say 1,200. 1,200's reported. It just totally changed the tenor of the room. Okay, I was shocked. Okay, because I never would the same number come up, for goodness sakes. Okay, because I knew no idea about that. So all of a sudden, it's like I was clairvoyant and told them something, right? Which wasn't the case at all. It was just a terrible, terrible coincidence. So at the time, there was so much frustration about we didn't have the right information, what were they doing, it was like out of control. It seemed like it was not the case, okay? But it was just a terrible coincidence of the same number being said and, what happened at that time. Now, when we said that, okay, the EMT immediately goes off in a discussion, led really by Harold, who was very frustrated. Say, we've got to do something. I mean, this situation is not in control. I said, I think we need to do something. Better we do something than nothing, okay? Now, hindsight, when you want quarterbacking, right? You look back and say, well, coulda, shoulda, all that sort of thing. We didn't verify, we didn't do a lot of things. They asked me, okay, what should be our evacuation recommendation? I wasn't prepared for that. I'm not an emergency planning guy. I wasn't. I was a systems engineering guy. I said, well, the planning basis is 10, but that's Harrisburg, and so, they immediately went into a dialogue, better we do something than nothing, this is just unacceptable what's going on. And it was unacceptable. But I said, I can't recommend what it ought to be. There's so many uncertainties here. But again, I don't know. None of us knew. And so they had this discussion about, we don't know. They said it was a crud burst. There's no crud burst. We know that. And so they went into a senior, better doing something not, okay? It wasn't a technical one. So I was excused. It wasn't a technical discussion anymore. So, when I left, this was 9:30. I've been up 24 hours doing this, not the brightest bulb, I'm sure I wasn't at the time. But I briefed my relief, Brian, what's going on? He said, oh my God, what are they doing? So he goes in and tries to slow this down a bit, okay? But it would kind of taken up. Now the commission got involved in it. Joe Henry, a very technical guy, but he had less information than we had, and we didn't have much. So it goes off, what's the right thing to do? And then, Doc Collins calls the state Pennsylvania Emergency Management Organization as opposed to the governor's office, and then they were kind of itching to go, and things got out of control. The sirens went off, but they shouldn't have gone off because the governor hadn't authorized the sirens to go off. It was just the newspaper was saying prepare for evacuation. It was a 100-ring circus going on basically in Pennsylvania at that time. And we at NRC, Bethesda, far, far away, were part of the problem, no question about it. Now I can look back and hindsight it and reflections. I mean, what should I have done? Yeah, I should have more emphasized about uncertainties and said, let us check what that 1200 MR. And we would have found out probably, because people knew, oh, that was the helicopter. That wasn't a site boundary dose. Okay, I mean, should I have done more? I wished I had. Okay, should I have cautioned? Yeah, I wish, but it is what it is. And part of, I think, what drove me, as I know it drove Denton and others, was the frustration for the last 3 days about you get the bad news 2 days later than what was really going on. So that really colored us, I think, in a lot of this, to overreact. And it was an overreaction, and based on reports that we'd gotten, which unfortunately, were wrong. Now I'm going to say something about the state of Pennsylvania. There's a lot of other things were happening to this thing. The state of Pennsylvania Bureau of Radiation Protection, okay, led by Tom Jaruski and Bill Dornsife and Maggie Riley. They were radiation people, working under the governor, at the site. They were remarkable. They had a much better handle there than we certainly did in Washington, okay? And they had a better grasp of it. I mean, when they heard that the Bethesda people had recommended through the governor, through PEMA, that there was to be evacuated, they said, what the hell are you doing? The IE inspectors, the NRC inspectors at the site went crazy. Says, I think the quote was from Greg Galinos, what the hell are they doing to us? I mean, and they were legitimate, their complaints about that were legitimate. I mean, if we could have, in Bethesda, could have talked with Bill and Maggie and Tom, at the site, it would have been a totally different thing, but we couldn't. We didn't. That's not what we had. The Pennsylvania Emergency Management Organization, Colonel Henderson, they were a little more, we got the sirens, we got the people, let's do something, he wanted to do something. And so you find these various things in the utility at this point were like on their back. I mean, they were keeping the main coolant pump running, they were keeping things running as best they could, but I mean, they were destroyed in the press. They were told, don't go to the press, don't talk. The NRC never had a designated spokesman. The two lead inspectors, Galena and Higgins at the site, neither one of them were designated who the lead was, so who talks to the governor? One time one did the other. And these were inspectors, good inspectors, but they weren't geared to deal with the governor at all. They weren't geared to deal with it. So they were in positions where they couldn't win. I was somewhat in a position where I couldn't win. I mean, it was just one of these sad state of affairs that kind of hit us. So, I mean, we did not do well. These were not our finest hours, no question about it. I mean, we took our licks. We, NRC, and certainly utility did, and the whole establishment did. But it was a shock that, okay, we got to change. And I mean, the fundamental TMI lessons that just totally changed the whole, nuclear business at that time. The man-machine interface capability. I mean, fundamental management concepts that had been the Naval Reactors program under Admiral Rickover. I mean, clear roles and responsibilities, authorities, safety culture, stronger technical staff, and communications became an important part. External communications, because you're going to live in a time. We never envisioned what the internet would do to us, but I mean, if you had the internet then, it would have been crazier than it already was. Then, Walter Cronkite saying on a 6 o'clock news, people in central Pennsylvania are in grave danger, of a nuclear meltdown, and people think the worst. The children. I mean, I had mothers with young children. I mean, they were going crazy about the whole thing, and you can understand why they did. When we moved there, my wife was a nurse and childbirth nurse and taught childbirth at the local hospital, and she still saw damages from this time, with basically young women, young mothers. I mean, they were the most stressed group. But back to lessons learned. Communications was an important part. I mean, risk-informed regulation became an important part, not just following the checklist in the book, really what are the fundamental safety aspects. So we overhauled, top to bottom within the NRC. The industry overhaul top to bottom. I mean, any ex-naval reactors admiral was hired as he became a utility president, okay? So things were changed drastically through the industry. I mean, clearly you integrate the management, the plant, the environment, the political, the financial, the social aspects of the accident prevention and mitigation and response, all were integrated together in the multitude of lessons learned things we did. So in general, the bottom line I like to make a point is what we learned. I mean, this really made the U.S. nuclear program safer, much more productive when the fundamental concepts that we had to do with it. And it prevented us, maybe some people say, from ever having a more serious accident. Because the fundamental systems did work, and it was contained. It was nowhere near as bad as people took it to be. But it was a big, huge wake-up call to us all that we needed to do better. And I think the NRC and the industry clearly has done that over the last almost 39 years, I would say, since that time. So, in general, that's kind of a little story about the details there. So I hope you have good questions that you might want to talk about or ask about in many other areas. So. All right.
Okay, so if you have questions, I'll give you the microphone. Just one reminder for our online participants, if you want to ask a question, please send it to SIREN, S-I-R-E-N, at vt, as in Virginia Tech.edu. Thank you. Please introduce yourself.
Lake, that was awesome. Just when I thought I had heard a lot of, I mean, not that I thought, I've heard a lot of TMI presentations, but I guess you can always learn something new, and thanks for that. Did I hear you say that, going back to the helicopter and the reading and your analysis of the waste gas and the release through the aux building, were there site boundary indicators that just weren't looked at, and people, because of the kind of the bad confusion between 1200 and 1200?
The actual, at that time, right, that morning, 9 o'clock-ish, the site boundary readings were 15 to 20 MR per hour. Now, that's pretty high for a normal plant. You don't get that in a normal plant.
For sure.
But it wasn't 1,000 MR per hour. So yes, we had, because they knew they had lifted the relief valve on the makeup tank, okay, and they needed to reduce the pressure. So they had to energize the compressors, and they had leaks in the vent gas header. So we knew there would be a uncontrolled release, I mean they couldn't control it, of noble gases primarily, and some iodine, when they degassed the tank. And that was going into the waste tanks. There was an error in the inspection reporter that said that the waste tanks were filled. When the waste tanks weren't filled, it was the relief valve lifted on the makeup tank. But because they knew they were going to do this, they had extra survey teams out at the site boundary downwind, and they were measuring 20 MR per hour. We didn't know that number, okay, but they were measuring. It was around 20.
So in the hindsight mode of thinking, that's not an evacuation number?
Correct. If we'd known it was 20 MR per hour, we would have said, no, there's no need to evacuate. There might be a need to precaution people, if you think it's going to get more, to shelter inside. Close your windows and stay inside. That might have been a more appropriate thing if we thought it was going to increase. Yeah. But in reality, it wasn't going to increase because the tanks were not filled. And there was iodine filtered released from the tank.
Movies are great. So this was a perfect storm.
It was a perfect storm as far as communications and scaring the hell out of people. I mean, it really was that.
Can you say, is there a threshold for shelter in place as opposed to evacuations that was enforced then as opposed to today? Is it still the same?
Yeah, I don't know. I don't keep track of what the latest policies are, but I mean, it always was, shelter in place puts a lot less trauma on the population. I mean, you can get the Fukushima stories. I mean, the evacuation itself causes more societal harm than the radiation. And clearly, the studies, the impacts of TMI were the psychological harm, was far greater than the radiological harm, and Fukushima has that in spades. I mean, suicides, and you try to move elderly people in hospitals and things like that. I mean, you are putting people who are already under stress that is far in excess of what the radiation risk and stress would be. So yes, sheltering was part of it, and it was discussed with the governor about shelter in place versus moving people.
But there's no hard number that would.
I don't think so. I mean, you had the protective action guidelines, where it was 1R at that time, and if you could get there, if you could stay within it by sheltering in place, you did so. If you think it's a quick cloud, okay, shelter in place. You know, don't go out in the cloud, okay? If you think it's a continuing release, say it was a containment failure and it was going to be continuing release for some period of time, then you evacuate people. As opposed to shelter in place. So it depends on the circumstances. I'm sure there's guidance today at the NRC, I just don't know what it is.
Please introduce yourself.
Hi, I'm Ann Kademian with Virginia Tech. Thank you. This was really interesting. I'm wondering how much of the transition to thinking about prevention, mitigation, response, how much influence 3 Mile Island and the response to that had on our more general all hazards approaches. You know, after 9/11, we kind of rediscovered all hazards and, you know, thinking about how to manage prevention, mitigation, response in a more comprehensive kind of way. Do you see connections between the way that U.S. policy responded to 3 Mile Island and some of the safety and prevention efforts, and how that links to some of the work, some of the more advanced work that we do now in that area?
It was the beginning of some of the integrated safety management concept you'll hear within the DOE sites, which is an offshoot of operational safety culture, which was a principle of Admiral Rickover and naval reactors. So you started to find more inclusive integrated safety management, which was a subset of integrated safety culture, you know, kind of thing. So yes, they started to fit together. You found it within the NRC, you know, risk-informed regulation. Okay, what's the risks involved here? And then you start thinking outside the box more. And then you get into, okay, OSHA rules and falling off a ladder versus radiation safety. It's really all the same. So you get into more of the comprehensive, integrated, all hazards type approach. So it's, in my opinion, it's sort of been an evolution of these over time off the fundamental safety principles. Okay, that you basically have a safety culture management kind of thing. So to me, they're all tied together and have evolved into higher states of evolution, really. But this was sort of the beginning of the big shock, I think, to the NRC and nuclear industry. Now, the naval reactors people tell you they had it all the time, and in many ways they did. Okay.
Blake, Jerry Hyatt with the Nuclear Energy Institute, and I can't remember in TMI, did they evacuate the nursing homes and the hospitals? Because the numbers I've seen from Fukushima is 2,000 people probably passed because they were either elderly and just couldn't handle the stress of the evacuation.
The governor said, okay, precautionary pregnant women and small children. That was the recommendation. Now, the local people were allowed to do what they could go more than that if they wanted to, and most did. Okay, so a lot of the nursing homes and some of the hospitals were, the local ones like Goldsboro, were evacuated. Harrisburg was not. I mean, the big hospital in Harrisburg was not. So I mean, so it was sporadic. It depended upon the hospital administrator or the nursing home administrator as to what they would do. It wasn't a mandatory thing like, say, Fukushima, where, okay, so many kilometers, you're all going, right? And you had huge impacts on society, per se. I mean, the quote, radiation cure was far, far worse than what the radiation risk really was. I would think that Fukushima has clearly proved that, and probably here. But there was no recommendation to evacuate them at all. It was only pregnant women and small children.
I've gotten a couple of online questions. I'd like to read those.
Sure.
So the first one is from a French participant, and I apologize for mangling that name. Charles Stössel, the director of Opus Citatum, Cabinet Council en Facteurs Humains et Management des Risques. So he asks, do you think the concept of resilience or resilience engineering could help to understand the TMI accident root causes? And the second question, do you think the operators, organization, nuclear community, society has been resilient during this accident?
Well, resilience. I believe the case of the United States and 3 Mile Island, we learned real quick we had big problems. And we were resilient, and we fixed them. We tackled them. We didn't try to, oh, no, we couldn't have prevented this. That was not our fault or anything. We all said, hey, we are somewhat all could have done. We should have served society much better than we did. Let's fix ourselves. So we were very resilient, in my opinion, and we responded properly, okay, as opposed to saying that was an act of God, we couldn't have stopped that, okay. So, yes, I believe we were. Now, as far as, resilience engineering, I'm not quite sure what that is, but I think we drew more on the probabilistic risk as to, what if this and what if that, and we look now much more closer to the man-machine interface. At the pre-TMI, you kind of said the operator was always going to help you. The operator was never going to hurt you. It was sort of a mindset many of us had in the NRC, and I guess I put myself in that thing. We never envisioned that an operator would turn off a high-pressure injection pump. When the computer says, I want water in the core, the operator turned it off. Now, there's a reason why the operators did it. They weren't bad operators. They were not evil people. They were trying to do what they thought was the right thing. But so, I mean, the resilient engineering and probabilistic risk, looking at these situations, made us change how we thought about it. And I think made improvements across the board.
All right, here's another one from Bob Budnitz, who says you're good friends.
Oh, yeah.
Lake, you didn't mention anything about the role in the first 4 to 5 days of the NRC Office of Research. He was RES Deputy Director. That is, he was Saul Levine's deputy at that time. RES had 150 technical people, plus 400 more at the labs, who were all mobilized and did a heck of a lot of work to answer specific technical questions as they arose. We ran thermal hydraulic analyses, we ran core melt calculations, we did metallurgical analysis about whether the vessel would hold if the hydrogen bubble were to explode. We did off-site dose calculations given what we thought the source term might be, et cetera, et cetera. We did a lot of analyses to answer questions as they arose, a vital role. Could you say a little bit more on the RES?
Yes, the entire American and probably some international scientific establishments all wanted to help and all tried help to do so, okay? I think we had a lot of problems integrating all of that science into usable, actionable information at the site or within the NRC. For example, I didn't go into the, quote, hydrogen bubble in the reactor vessel and the potential explosion, okay? I was not personally involved in that, so I really can't speak to that, but Bob was. And that was a very difficult time because the NRC, some parts of the NRC felt that the gas bubble could be explosive and we should maybe be evacuating people based on an explosion potential. And that was wrong. There was too much hydrogen in, there was no oxygen, okay? But what happened was people were asked isolated questions. What is the worst thing that could possibly happen? What if there was hydrogen and oxygen in it and it was explosive? Hundreds of calculations like that were done. Would the vessel burst or not burst if there was an explosion of hydrogen and oxygen inside? Never mind, it was impossible to have both together, okay? Which many scientists said, you're thinking all the wrong things. That's impossible. Why are you doing that? So there were many cases, well-meaning analysis people who were very smart, very good degrees and all of this. It made a lot of noise in the system that, in my opinion, many times was counterproductive to what reality was. So it's hard to harness the science and maybe academia or in a national laboratory into actionable action by the people on the ground at the time to tell the governor, yeah, you should or shouldn't do that. It was integrating that together into actionable information was a real challenge. But yes, the hundreds, probably thousands of highly qualified, very capable technical people, did all sorts of analyses all night long, all day long, worked very, very hard. But it was very hard to utilize a lot of that in actionable decisions. But yes, Bob and many of his colleagues made calls all night long and had good analyses done, but they were hard to use.
John Medeiros, Virginia Tech. I actually want to follow up on what you just talked about with all the available information. Now, looking back in the postmortem of the evaluation, did you find that there were some critical data machinations that were done or information that could have been helpful to you by those subordinate groups? Had you been aligned more along, say, incident command system structure, or weren't trying to use a 300-mile screwdriver from the NRC type approach? Any of that done from a postmortem point of view? Thank you.
There were a lot of analyses done about what would have been better, et cetera. A lot of times, I think what became a problem is how do you get the right information to the right person at the right time? There were people who were telling Bob, and Bob was one of the leaders gathering information on the bubble. I mean, someone said, there is no oxygen because it's overpressure hydrogen, and PWRs, Navy, as well as the commercials, I mean, they put hydrogen on purpose, and there is no oxygen because it reverses the reaction the other way. People said that. But there are others who were saying, well, I was asked to look at it, what if it was explosive? And the vessel would or wouldn't burst. So both are right, but which one are you using? So yes, clearly the structure of what you're asking, how you're asking it. I mean, Vic Stello, who was an excellent engineer, my boss, he was the one who had his old Keenan and Key steam table out and said, those temperatures are superheat. You can't, but he tried to talk to the control room, but he talked to one of the operators who was a junior operator. We said, well, I'll tell the management. Well, it never got to the management people, okay? So, I mean, it's like the wand of the horseshoe nail, and the horseshoe nail was lost, the message was lost, the war was lost, and the king was lost. I mean, it was that kind of thing where if we'd had a more responsive, resilient command control structure and communications, which the NRC has now, and the industry has, we would not have had this problem. If TMI were to happen today, and the operators were to make a mistake and turn their pumps off, I mean, clearly the system would quickly catch that and correct it. Okay? Then we did not have that. We were complacent. I mean, I would say we didn't expect this kind of to happen, kind of thing. We never expected operators to turn off injection pumps. So yes, today I think we'd be much better at it. But it's hard to, and I saw it at Fukushima as far as information flow, and an analysis person would do this in a national laboratory, and how do you get the right information to the right decision makers at the right time when there's so much uncertainty, the fog of war, the fog of the accident, when nobody knows. I mean, in Japan they would talk about, well, TEPCO didn't tell us the truth. Well, I mean, I explained to people, I said, if you were in the control room with the people, they didn't know. They thought they could get cooling, and they were trying to prevent, a meltdown. They didn't know themselves if they would be successful. And then the same thing with the operators at TMI. I mean, they were trying to cool it or trying to control it. They didn't understand why they were getting all these readings. Then they invented, certain instruments would tell them they would believe the instrument that they thought would be the right answer, and the one that was giving them a strange anomaly, they disregarded that instrument. Well, that's instrument failure. That radiation level couldn't be that high. But this is a pressure I'm comfortable with. I mean, there were many psychologists looked at TMI after and the behavior of the operators, and it was interesting what some of them had to say as far as how people respond under pressure, and you tend to gravitate towards something you're familiar with, and so now you train on simulators to those sort of things. So there an awful lot was learned to improve safety across the board.
If I may jump in here really quick,
here.
and then I'll come to you. But just to follow on, these improvements that you mentioned, in terms of training, in terms of communications. In one of your earlier slides, you had this remarkable text that said, there was no place to think. So has that been addressed? I mean, the man-machine interface compatibility, I understand you can change the switches and the lights and the alarms and train people on simulators to be comfortable with that. But the physical layout of these plants has...
They were changed.
They were changed?
They were changed. We got shift technical advisors, degreed engineers that were placed. There was, glass partition set. You go back over here and think what you're doing. Different people had assignments to overview the whole thing, and all the drills and the emergency response procedures in NRC and also at the utilities were set up to have room to think and time to think and step back away. If the first engineers who came in at 6 a.m., if they'd had time to step away from 100 alarm lights, okay, and stop and think of fundamentals, they would have had it right away and told the operators I kind of forgive not knowing. Engineers kind of showed up. I'm not as forgiving, okay? But then I said, okay, they were told when they showed up, some of them, to put on respirators because they'd misread the iodine readings because they had noble gas in the carbon cartridge, so they thought they had iodine. They put on full-faced air masks. You can't talk in a full-faced air mask very well at all. Yet these were the engineers trying to figure out what's going on. So yes, that has been changed a lot. And physical changes as far as ventilation systems, procedures, professionalism and degrees, and what you understand in training, and quiet places to think. We didn't have quiet places to think at the site. Now, we did at headquarters, but they didn't.
Doug Bain, could you compare and contrast the TMI evacuation with the Hurricane Katrina evacuation in New Orleans?
I don't know much about Hurricane Katrina other than what I'll read in the press, and I give that 10% usually. I can speak to Hurricane Irma in Florida. I live in Florida, and I think they did a very good job in Florida on it. Katrina, I think it's very complicated. The mayor was in charge, but the mayor and the police, and it gets so complicated, I can't go there. TMI had its problems, but I mean, there was clearly, everyone was competent. The governor, I think, was very competent. The mayor of Middletown, everybody really, in my opinion, did a great job with what they had. And unfortunately, they didn't have all that they needed to make the right decisions. I think Katrina's got a whole lot of other issues that are much more dangerous.
I think it's fair to say that the evacuation planning, at least from what I understand, the evacuation planning done for nuclear power plants have been exercised for other reasons to evacuate, for chemical spills on railroads, maybe hurricanes, and they proved to be pretty efficacious. So, I mean, that's one of those spin-off results that you say, not just is the nuclear world the better, safer, but we've learned a lot of lessons from the nuclear.
FEMA didn't exist. FEMA, I mean, many of the lessons from FEMA and others as well expanded upon. I mean, if New Orleans maybe had a nuclear power plant and had some of these training and planning, probably Katrina would have been a whole lot better, but they didn't. I mean, there's not a nuclear power plant in New Orleans.
TMI, we didn't have that. So it wasn't as organized as it would be today.
Doug?
I'm Doug Chapin, NPR. Lake and I know each other from a while back in these accidents. The point I'm trying to make is what you guys are saying here is, if you're going to deal with an accident, if this whole thing in SIREN and everything is how you deal with an accident, how do you deal with these kind of events, is you think about them ahead of time, then you get all the people involved who have to work on them, and then you practice. And you do that with the people in the plant, you do that with the police, you do that with the hospital people, you do that with the whole crew, and you say, we're going to have an accident here, and what do you think is going to happen? And everybody thinks about it, and then you go practice. And that's what you need to do, and that's what's needed to be done from the beginning. And if you want to compare with what happened at Fukushima, nobody practiced, nobody done anything to prepare, nobody thought he was going to have an accident like that. And so when they had evacuations, they killed hundreds of people. When they have all sorts of problems, but But let me tell you, what we learned out of 3 Mile Island and what the Navy had learned in the early days before we got to 3 Mile Island and other people need to learn is if you've got something like this, you ought to think about what accidents can occur, and you ought to figure out what you need to do to deal with them, and that's what you need to practice.
Practice and training is a key thing. Yeah. I'm not sure I got the nexus between the Katrina and TMI enough.
Yeah, it seemed to me that one big part about it was that it was a local management or governance of the evacuation. I mean, they had the buses, but somehow they just didn't use them and things like that. And also, people didn't believe that there was really a problem. And a minor point was they wouldn't take pets. So people said, I ain't going without my dog.
That becomes a practical things that you see through practice. You know, if you really practice it, you'll find those things out. I mean, like the pets. I mean, we learned that, you know, in Norman that certain shelters would take pets not, and how that was all going to work in the right numbers of people.
I have one other question.
I think they might need this for the web.
Yeah, they can't hear you unless.
There was always a rumor going around when I was at NRC that apparently the plant TMI-2 had been brought up to power, full power, in December of the previous year in order that they could get a investment tax credit, and there was red tags on instrumentation, but they ignored it. Is that true, or?
I don't details on that. I don't think it's true. I mean, I'm not going back into that. In the business, there's always, you know, an urgency from a finance to bring things online. But I mean, they cannot, abuse that. I mean, can you have material inconsistencies and procedures for that? Yes. Can you have red tags? Yes. You have red tags on cars and everything else. I mean, but they're controlled. So I don't know of any case where in 3 Mile Island, in any of the investigations, and these were all independent investigations, there was any willful misconduct by GPU or Med-Ed to short circuit for financial reasons at all, and that was looked at pretty closely. So I don't believe there's any truth to that at all. But you can't say there was never a deviation, situation or anything like that, but not of substance that had safety to it.
Any other questions, comments? Okay, I have one more. All those innovative tools that you showed us that were developed and designed to dismantle the destroyed parts of the core, are they still around? Did you hold on to them? Were they, are you still training with them? And the reason I'm asking is also because after Chernobyl, they got a lot of international assistance, but only a fraction of those robots and instruments actually worked. And very few, if any, of those have been preserved and maintained properly. And so I'm, now that they have covered the fourth reactor at Chernobyl with this new safe confinement, I'm wondering if they are still around from 3 Mile Island or similar tools, whether you have any tips for decommissioning, dismantling the remains of Reactor 4 at Chernobyl.
Well, as far as the tools, many of the tools are at Idaho, because Idaho National Laboratory was the DOE support who developed many of the R&D tools. Like the core boring machine, that was developed as an R&D tool to get a core sample all the way down to the bottom, but then it became a defueling tool to actually break up the core pieces. So you found the R&D government developed piece of equipment became a production piece of equipment for defueling. So that it still exists, for example, in Idaho. And some of the big cask I showed you that was made, those exist still. They haven't thrown those away. They're multi-million-dollar casks, but they're specialized, for it. So a lot of the was recorded. There are many reports that were written by DOE to capture the knowledge. Many of these reports were translated into Japanese for Fukushima, and we've had workshops of 3 Mile Island experience, for the Japanese. They're very cognizant of what we did and learn from what we do. We had lots of robots in believe it or not, even back then. Most of them didn't work. They were not applicable to use in the plant. I mean, we had the one at Louis, was a big fancy thing, and if we get in there, get it contaminated, we'll never give it back. And yeah, we had with Carnegie Mellon, we had a partnership developing, and they did do a good job developing practical things. It was very difficult to have a practical, usable robot on a time frame that was appropriate, as opposed to, I have a neat idea for sun that I'll have in 5 years. Well, that's too late, I'm sorry. Chernobyl is a different thing. That was an RBMK graphite reactor, not water reactor at all, not a light water reactor. So Chernobyl is very different, physically different. I mean, yes, it's highly radioactive, and yes, there's core slumping and core melt, and some of the tools are appropriate and not. But I mean, we worked underwater at TMI. Chernobyl's not underwater and never will be. Fukushima, some probably not. But I mean, we have more capability. But we had a lot of robots that we didn't use because they just were not practical, and it's a big challenge to take, let me say, academic theory at a university and apply it to an auxiliary operator in a plant. It is a huge gap to bring that together. And we spent a lot of management time into how you integrate that into an effective, D&D operation. And that's what the Japanese are working on very much now with the advanced, underwater robots and advanced robots of today, which are far in excess, to get it in an applied manner, where it can withstand, for example, high radiation and not have the TV camera fry in the robot and it's blind. And we have that problem. So we are doing it, but a lot of the tools were pretty simple. We had a process for the cleanup was, the KISS principle, keep it simple, stupid. Unless it's been proven, let's not develop some brand new thing that you got to do, you got to develop it and make sure it's going to work. It may be great on paper, and that a lot of the robots that were proposed for TMI fell behind and we didn't use them for those reasons. They weren't practical.
I guess my question goes more in the direction of, do we have to reinvent the robots and the wheel every time we have a severe accident?
No, I don't think so. I mean, in the case of Fukushima, I mean, there's a lot of robots in, say, law enforcement, right? I mean, for bomb disposal. I mean, those things were there right away. Okay, we have drones at Fukushima. We didn't have drones then for TMI. So I think you take the state of the art of the knowledge. The French CEA had some very nice, incident response robots, and the Japanese use them. Okay, and so you take the technology that you have, the state of the art, and you apply it. It's a challenge, though, when you have to make it, into nuclear grade, basically, to take it the next step up. I mean, I liken to say the American space program. I mean, President Kennedy was going to put a man on the moon in 10 years. We had theory for rockets, but we didn't have rockets that size. We didn't have a lot of things. So as NASA developed it, I mean, you develop things like flat wire, right? We didn't have flat wire, but that became everywhere. So you had spin-offs of technology into basically commercial technology. And I think some of the robotic work being done today at Fukushima will be the same kind of thing. We're going to learn from those, and there'll be spin-off, as well as there's, say, drones and underwater technology for, say, underwater, deep water drilling, robots and drones and underwater manipulators will be used at Fukushima, and some of those could be used, at Chernobyl, but Chernobyl, it's very complicated.
Any other questions? Yes, go ahead.
Again, John Medeiros, Virginia Tech. Two areas have been highly researched: wildland fires, and nuclear power plants for highly reliable organizations. And if there's one thing I've learned through my just reading of the literature is practicing for failure, not necessarily for success. And as a mindset, what's going to fail? How do you deal with that? And so the question is, within this world now, nuclear power plants, is that mindset in place, do you think, for practicing and working against failure rather than trying to achieve success? I realize those are a little bit counterintuitive, but I think you understand where I'm going.
Yeah, I think we do both. I think modern society, let me say, Western Japanese society and nuclear is doing both. Yes, you have a goal for economical, safe power, Okay, so let's develop a reactor system, be it a small modular reactor, whatever it is, or space reactor for power. You start, safe and perform, and then you apply, risk-informed risk analysis. Okay, what can go wrong here? What's my fault tree? What's my probability of my various trees? And examine it all the way on down. And so you're looking for failure. You are looking as much for failure, if maybe not more so, as far as hours as you are for just success. So it's not just success, it's success and failure. Because if you don't have a goal, what am I really trying to do, you kind of lose sight. Well, let's find out what's wrong and why am I doing it all? If you want clean, carbon-free power, you have so many limitations.
All right, we're out of time, but Lake will stick around for a little while. So if you have further questions, please join us. There's still some food and some drinks left outside as well. Thank you, all our online participants, for joining us. Please join me in thanking our speaker for a fascinating talk.